today. We are going to be treating the salt analysis of this year NECO chemistry practical. So we are going to be carrying out the test and the observation, then we are going to treat the questions under it. Likewise, I'm going to display the practical procedure of the test. So if you are new in this channel, I want to please beg you for three things. I want to beg for three favors. Kindly comment, subscribe, and do give us a like. If you subscribe, at the end of this video, I'll be dropping the question, both the test, observation, and the inference. So let's go into the practical, right? With two salts, and we are going to carry test, observation, inference on these two salts. X, which represent our zinc trioxocarbonate 4, ZnCO3, and our Y, which is aluminium chloride, AlCl. My X, and then we are going to carry out dry test on X, because the question asks us to carry out test on X, and we are also going to carry out test on Y. And this is my X. So there was a video I released like 2 or 3 weeks ago. Check the link there. That you see the link in the description button. Dry test on trioxocarbonate 4. So carry out dry test on trioxocarbonate 4. The one that will not liberate, those are the ones that are stable to eat. They will not liberate carbon 4 oxide. Okay, so think trioxocarbonate 4 will liberate carbon 4, and that is why you must give. So the question says, put a little portion of sample X in a test tube, then eat, test for any gas that may involve. Now, I said initially that I'm going to drop the link in the description box whereby I talked about test for trioxocarbonate 4. By the time we hit trioxocarbonate 4, I mean zinc trioxocarbonate 4. Virtually every trioxocarbonate 4 will liberate carbon 4 oxide gas. Every trioxocarbonate 4, except sodium trioxocarbonate 4, then potassium trioxocarbonate properties of carbon 4 oxide, and chemical properties of carbon 4 oxide in the observation for you to get 2 marks. Now, the physical properties of carbon 4 oxide is a colorless and odorless gas. That one is 1 mark. Which terms lime water milky? Now, that is the gas that will be produced when we eat zinc trioxocarbonate 4. So, and that is carbon 4 oxide gas. So, under the observation, we are going to have effervescence of a colorless and odorless gas, which terms lime water milky. And then the gas will be what? The gas will be carbon 4 oxide. From what? From CO3 to minus. Then the next column said, eat the portion strongly in the above and allow to cool. Now, we are going to have residue. Now, immediately carbon 4 oxide leaves zinc trioxocarbonate 4. We are going to have zinc oxide. And the real practical is shown down below. The real practical is shown down below. Now, zinc oxide is yellow when hot and white when cool. So under our inference, we are going to have zinc oxide is present, but under our observation, the residue is what? Is yellow when hot and white when cold. So now this is my Y. I have added water to my Y now, and then Y is actually soluble. That is aluminium chloride. Aluminium chloride is soluble. So now the question asks me to add water to Y. Actually, Y dissolves completely to give a colorless solution. That's our observation. That at our inference, it means that Y is a soluble salt. Next column asks us to divide Y into 2 portions. We want to divide Y now. So we have divided Y into 2 portions now. Then the first one we are adding sodium hydroxide, then the second one we are adding aqueous ammonia. Sodium hydroxide. This is my sodium hydroxide. I'm adding sodium hydroxide to the first portion right now. Now, because of the screen, I might not be able to see, but there is a white gelatinous precipitate. There is a white gelatinous precipitate. And when we say white gelatinous precipitate, it means that it looks like a starch. It looks like a starch, and that's why you must know the theory of practical. Because I've already known that it is aluminium that is there, and zinc and aluminium have that property. They are the one that give a gelatinous precipitate. Zinc and aluminium both give a gelatinous precipitate. So in my observation right now, I'm going to have a white gelatinous precipitate, and at my inference, Zn2 plus, which is zinc ion, or aluminium ion, which is Al3 plus, is what is present. I'm going to add sodium hydroxide now in excess. Now in excess, the precipitate dissolves. The what? The white gelatinous precipitate do what? Dissolve. The gelatinous dissolve, that shows that both Zn2 plus or aluminium, which is Al3 plus, is present. Both zinc and aluminium ion give the same test with sodium hydroxide. I will also drop the link to distinguish between Zn, aluminium, and Al3 plus. So to the second portion now, we want to add aqueous ammonia. The first portion we add sodium hydroxide, and I said that both Zn and Al3 plus both dissolves in sodium hydroxide. Now we want to differentiate between Al3 plus and Zn2 plus right now with aqueous ammonia, and this is my aqueous ammonia. So let's add aqueous ammonia and see what happens. In drop, we are still going to observe a white gelatinous precipitate, and then in excess, at the bottom you will see the precipitate still remains, and that shows that the aluminium is present. Which is Al3 plus. Aluminium is present. Al3 plus. That is aluminium ion. So aluminium ion is present there because it is the one that forms insoluble precipitate with what? With aqueous ammonia. So please, if you have added value to you in this video, kindly subscribe, give us a like, and drop your comments in the comment box. I will see you next week Friday.